Welcome to Ask and Learn.
We want to use the asymptotic behavior of sine of x plus e to the negative x to go ahead and help us sketch this graph without going through the whole process that we've done in this chapter so far. So to get some inspiration as to what the asymptotic behavior of this might be, let's go ahead and take the limit of each of these functions individually so we can get an idea of where each of them would go. So let's do the limit as x approaches infinity of sine of x. Well, we know sine of x continuously oscillates between 1 and -1, so it never gets closer to anything. So we know that this limit is not going to exist. And we can say the same thing for the negative infinity as well. So for plus or minus infinity, sine of x doesn't do anything. Now, we know the limit as x approaches infinity of e to the negative x. Well, this here would go to 0, because remember, e to the negative x. This is really 1 over e to the x. So we'd have something going to infinity and dividing that into 1, or a constant, so that should go to 0. And now let's check for the other side. So the limit as x approaches negative infinity of e to the negative x. Well, this here would be the same as the limit as x approaches infinity of e to the x. And well, e to the x goes to positive infinity. So if we were to maybe make a guess, so the limit as x approaches infinity of f of x, we might make the guess that this goes to sine of x, since we found that e to the negative x goes to 0 in this case. And the limit as x approaches negative infinity of f of x, we would suspect that that would go to positive infinity, since sine of x is just bound between -1 and 1, and e to the negative x goes to infinity. Well, we can at least show this one has that slat asymptote by doing what we've done in some of the previous problems in this chapter. And remember, to do that, what we want to show that the limit as x approaches infinity of f of x minus sine of x, we want to show that this is equal to 0. So if this is the case, then we know the behavior as it goes to infinity will be sine of x. So let's go ahead and plug everything in. So we have the limit as x approaches infinity of, well, f of x was sine of x plus e to the negative x minus sine of x. These sine of x's cancel out with each other. Then we have the limit as x approaches infinity of e to the negative x. And again, that's 0. So that one checks out. So we know as it goes to infinity, it will be sine of x. So now let's go ahead and use this information to help us graph it. And one other thing that we should probably do before, let's find f of 0, just so we have an idea of where we're starting. So we're going to have f of 0 is equal to, well, sine of 0, which is 0, and then e to the negative 0 would just be e to the 0 or 1. So f of 0 is 1. All right, so we can go ahead and plot that there. And now we know to the left of this is just supposed to go off to positive infinity, and to the right, this function should get really close to y is equal to sine of x, which I have graphed here in red already. So it probably comes up like this, goes up a little bit, and then it gets really close to this red line, and just kind of wiggles around it in some sense like that. And this is how we could go about getting at least a sketch of the graph without going into too much detail.